Welcome to today's class. Our topic for today is still steady state DC circuit analysis. So we are going to the third stage. We've done steady state DC analysis 1 and 2. In the first analysis, we talk about Kirchhoff voltage law and Kirchhoff current law. And we talk about node analysis and we talk about mesh analysis, whereby you use them to solve DC circuits, direct current circuits. Now, in the steady state, second steady state law analysis 2, we talk about superposition, Thevenin, and we talk about Norton. We use them to solve DC circuits. So in this case, we'll be talking about another principle. We'll be talking about star data transformation, source conversion whereby you convert from voltage source to current source. We also convert from current source to voltage source. In this case, we'll convert from star to data and also convert from data to star. So we'll do the two together, star to data and data to star. So let's move to the first one, star to data. Now notice that your star can also be called wide connection. We call them Y connection. So note, your star is also called what? Y, which is called Y, is pronounced as Y connection because your star is like this, while your data is like this in this form. We'll get to that. Now, resistor are sometimes either not connected in series or parallel. You know, we've been talking about resistor connected in series, resistor connected in parallel. But in this case, there are some resistors they are not connected either in series nor in parallel. So you can't say this resistor is in series or they're in parallel. So all these kind of resistors are either in data form or they're in Y form. Let me give you an example. Let's assume you have a connection like this. In this case, you can't say maybe it is series or what, or parallel. This is Y connection. You can't say this and these are in parallel, this and these are in parallel, or they are in series. So we now use another method, which is called what? Star to data transformation or data to star confirmation. So in the transformation in this form, this is Y Y form. We're going to transform it to what? Data form. So in this case, a special technique needs to be used for simplifying analytical circuit. So we now use another form, which is the star and data transformation to what? To analyze our circuit. This technique is known to as what? Data to Y. Data to Y means what? You are converting from data to Y, or Y to data, and Y to data means we are converting from Y to data transformation. Consider three resistors which are shown which are connected in data and Y form as shown in the figure below. So this is your data form, this is symbol for your data. That means you have your resistor in data form. So this is still the illustration. This is your Y form. Your resistor is in what? In Y form. So now, if you want to convert from your data to your Y, from your data to your what? To your Y. Now, for your data to your Y, that means you are going to be given this RA, RB, and RC. Let's assume you are giving all these resistors. They want to know your R1. So your R1 now will be the what? The product of RA and RB. RA, RB, their products divided by the sum of all the resistors RA plus RB plus RC. That's RA plus RB plus RC. So that's your first transformation, your R1. Note, anyone can be your R1. Anyone can be your R1. But if you take this together as your R1, that means we are taking another one. This will be your R2. That means I'm going to take RB and RC. I want to take your R3. You take this. So that is just the combination. Now look at your R1. It is combination of what? RA and RB, then divided by the sum. That's your R1. Now your R2 now will be what? RB and RC divided by the sum of RA plus RB plus RC. So the R3 now take RA and RC divided by the sum, which is RC times RA divided by the sum. Now this can be R1, this can be R2, R1, R3. Anyhow, you can take them in any direction, but make sure that is when you are calculating this that you don't make mistake. Your R1 should be the combination of these two. When you want to calculate your R2, don't use the combination of these two again. You have to use the combination of the other one. Then if you want to calculate your R3, you use the combination of the what? The other. So let's look at this is data to Y. You are converting from data to Y. Now let's convert from Y to data. Now I want to convert from Y to data. Now you have your Y connection. In Now I want to go to your data connection. Now to get to RA, now your RA will be what? Your R1 R2, the product of these two, R1 R2 plus the product of these two again, R1 R3 R1 R3 plus the product of these two now, R2 R3. So you take the two product of each of them divided by R2. That's the RA. Now this can be R1. This can be what? R1. But if you are taking your RB now, if you take this as your R1, that means your RB now, you are going to have R1 R2 plus the same thing R1 R3 plus the same thing R2 R3 divided by what? So since you've taken R1 as this, that means this should be R2. Now to get to RC now, it will be what? R1 R2 plus R2 R1 R3 same thing plus R2 R3. You notice that the numerator is the same thing for all, but what we differ now, this is R1, this is R2, that means this has to take the third one, which is R3. So that's how you transform from your what? From your Y to your what? To your data connection. Now we use all this in different application. We use them in different application to change from series to parallel, from parallel to series, in case if you are not able to see if this is in series or in parallel. So if you transform them, you're able to know this is in parallel, this is in series. When we are solving question, you see how it is being applied. So we've seen the conversion from star to data, and we've seen the conversion from data to star or data to Y. Anyhow you want to use it, you can use data, you can use Y, or you can use star. So this is the conversion. These are the formula you need to note. Note this formula. This is from data to Y. That's the formula. And note this formula. Note this also. This is from your Y connection to your data connection. So let's go to the first example. Example 1. A data Y circuit is shown in the figure below. Calculate the total circuit resistance and the current source and the power absorbed by the 4 ohm resistor. So I have to calculate the total circuit resistance, so R equivalent of all these circuits. You have to know the equivalent resistance of all these circuits. So if you know the equivalent resistance of this circuit, it's very easy to know your I source, because you're going to have something like this, plus minus your I source that is flowing out from the battery. Now if you know the equivalent resistance, which is R equivalent, so this is your V. So it's very easy to know your current, because using Ohm's law, V equals to what? The current supply times R equivalent, Q equals to IR. So now to know your I will be equals to what? The voltage supply over your R equivalent. So you are given the voltage supply already, which is 50. So we have to know the R equivalent first. So this is easier. This is easy. Then to know the current, to know the power absorbed by the 4 ohm resistor, that means you have to know the current being supplied at this. And what was the power? Your power will be equals to what? I square R. So if you know the current flow in this 4 ohm resistor, you're able to know the power absorbed by the 4 ohm resistor. So let me rub this and let's start with the analysis. Now we are given this connection. In this connection, we can't say maybe these are in parallel or they are in series. We can't say maybe this is in parallel or they are in series, or this is in parallel or they are in series. We can't say exactly, but we know that this one here or this one here, anyone you want to pick out of the two, look at this, it's like a data connection. Look at this wire, these two wire here, I'll combine them together as one wire because it's just a wire. You can combine them at just one point. So this will now be 6 ohm resistor coming like this, and this 10 ohm resistor, and then this 8 ohm resistor. So this is this here. So or if you can do the same thing to this, so I'll combine these 3 wire together, this wire here as one, so to be a dot, then 3 ohm resistor like this 3 ohm resistor here, then there's a dot here to this 10 ohm resistor, and then to this 4 ohm resistor. So you notice that this is a data and this is a data. So let's convert it to Y connection. So by converting to Y connection, it's very easy for us to see by converting to Y. So let me see the Y connection. Let me show you the Y. So if it is connected to Y now, you're going to have something like this. So this is a Y connection. This is a Y connection, or your Y connection can also be in this format. Your Y connection can also be in this format, but this won't help. I'll use the other one, because if you have the Y connection in this format, you will be saying maybe they are in series or they are in parallel again. The only thing I'm going to say is that these two will be in parallel. That's the only thing you're going to see directly. Okay, we can use any of them. We can use any of them. Let me use this so that you understand that you can also try the other one. So let's see this. So that means this, there will be a resistor here for your Y, a resistor here for your Y, and a resistor here for your Y. That's a Y connection. So we need to know our Y. Look, let's call this R1, R2, R3. So this is your RA, RB. You can name it anyhow. RC. The naming does not change anything. So this is RA, RB, RC. So let me rub off this. So let's find our R1. From your data to Y, what do we have? From data to Y, we have what? The product of the first two with what? The sum of all the resistors. So the product of any of these two. So your R1 now will be equals to what? RA, RB plus RA plus R. Okay, let me find RT now. RT to be equals to what? RA plus RB plus RC. So I don't want to be using RA plus RB plus RB. I'll just be using RT. So instead of RA plus RB plus RB, what's not my RT? RT equals to what? What's RA? RA is 6, RB is what? 8, then RC is what? 10. So 6 plus 8 plus 10 will give us what? 6 plus 8, that's 14. 14 plus 10, that's 24. 24 ohms. So now let's do that. What's our RA? Our RA is 6 times, what's our RB? Our RB is 8 divided by, what's our RT? Our RT is 24, sorry, 24. So 8 here 1, 8 here 3, 3 here 1, 3 here 2. So 2 times 1, that means our R1 is what? 2 ohms. Let's find our R2. Our R2 equals to what? Since you've used RA and RB, you have to use what? RA and RC. So don't use RA and RB again. That's what I'm trying to say. So that means RA and RC divided by what? The R total, which is RA plus RB plus RC. What's our RA? Our RA is what? 6. What's our RC? Our RC is what? 10. What's our R total? Our R total is what? 24. 4 here 1, 4 into 24, that's 4. 10 divided by 24, that's 2.5 ohms. That's our R2. Now let's find our R3. Our R3 now, you've used RA and RB, RA and RC. So the next one is what? RB and RC that I'm not using. RB and RC divided by R total. What's the RB? Your RB is what? 8. What's the RC? Your RC is what? 10. And what's the R total? Your R total is what? 24. 8 here 1, 8 to 24, that's 3. 10 divided by 3, that's what? 3.33 ohms. So that's the R1, R2 and R3. So let me redraw this circuit so you can see it very well. So I'm going to have this. You're going to have this. Let me draw it here. Plus minus 50 volts. Your 2 ohm resistor is there. Now instead of having this instead of having RA, RB and RC, you're going to have what? A star connection. So when you get to this place, you're going to draw a star connection, which is this, like this. Yes. Then also another one here. So that's a star connection. Now you're going to have it downward. here, then also this, that's a Y, then to this, then to this, then to this. So this is a Y connection. So this is the diagram. Then let's complete the diagram, this and this. So this is our 2 ohm resistor, which is this 2 ohms. This is our R1. What's our R1? Our R1 is 2. This is our R2. What's our R2? Our R2 is 2.5. This is our R3. What's our R3? 3.3. Then this is our 3 ohm resistor, and this is our 4 ohm resistor. Note that we converted this and this to this Y. That's why they are not there again. So this is now the Y connection. Now let's calculate the equivalent resistance of this. Automatically we can see this and this are in series, the same current to flow through them. So that means the equivalent of this will now give us what? R equivalent of those two of these two will be what? 2 plus 2, since they are in series. That's 2 plus 2, which is what? 4 ohms. Note also, this and this, they are in parallel. They are in what? Parallel. So the equivalent of them will be what? The equivalent of this loop, because to what? 1 over R equivalent to be equals to what? 1 over 3 plus 1 over 4. What's the SCM? The SCM is 12. 3 in 12, that's 4. 4 times 1, so 4. Plus 4 in 12, that's 3. 3 times 1, 3. So I'm going to have what? 7 over 12. So take the reciprocal of both sides. That means your R equivalent will now be equals to what? 12 over 7. So let's redraw the circuit. Also note this and this, they are in parallel. This 2.5 and 3.3, they are in parallel. Let me draw it for you so you can see. Look at this 2.5. I can bring this resistance here, which is this, and look at this 3.3. I can draw it like this. So this is this here. So they are in parallel. So what's 2.5? 2.5 is what? 5 over 2. Your 2.5 means what? 5 over 2. What's 3.3? Your 3.3 means what? 10 over 3. 10 over 3. So since they are in parallel, let's find the equivalents. So that means for this loop also, so that means the 1 over R equivalent for that loop will be equals to what? That's 1 over 2 over 5. That's 1 over 5 over 2. Sorry, 1 over 5 over 2. That's 1 over, I said 2.5 is what? 5 over 2. That's 1 over 2.5, which is 5 over 2, plus 1 over 3.33, which is also what? 10 over 3. So 1 over 5 over 2 will give us what? 2 over 5, plus 1 over 10 over 3 will give us what? 3 over 10. That's just the reciprocal of them. What's the SCM? The SCM is 10. 5 in 10, that's 2. 2 times 2, that's 4. 10 in 10, that's 1. 1 times 3, that's 3. So I have what? 7 over 10. So let's now redraw the circuit. Let me cancel this. Let's redraw the circuit and see what we have. Okay, I can't cancel that. Let me cancel this. We have now our R1, R2, and R3 already. I'll still use the second direction for your star to see maybe we are going to get the same answer. So let's redraw it. So this is 50 volts. We are still going to have it, our 50 volts plus minus 50 volts. Then this and this already give us what? 4 ohms. So the combination of these to give us what? 4 ohms. So that's a 4 ohms. Also note, the combination of these two gave us 7 over okay, no, not 7 over 10. So that means our 1 over R equivalent is what? 7 over 10. So let's find the reciprocal. That means R equivalent will be equals to what? No, we are looking for R equivalent, not 1 over R equivalent. Since 1 over R equivalent gives us 7 over 10, that means R equivalent gives us what? 10 over 7. If we take the reciprocal of that, 10 over 7 ohms. So that means the combination of these two give us what? 10 over 7 ohms. 10 divided by 7 ohms. Then the combination of these two give us what? 7 over 12 ohms. Twelve over 7 ohms. 12 over 7 ohms. So now we complete it. So therefore, these three are in what? They are in series now. That means the R equivalent will be equals to what? 4 plus 10 over 7 plus 12 over 7. What's the SCM? The SCM is what? 7. 4 in 7. Okay, this is 4 over 1. 1 in 7, that's 7. 7 times 4, that's 28. Plus 7 in 7, that's 1 times 10, that's 10. Plus 7 in 7, that's 1 times 12, 12. So 28 plus 12, 28 plus 10, that's 38. 38 plus 10 plus 12, that's what? 50. Then divided by 7. So what's 50 divided by 7? That means the R equivalent will be equals to what? 50 divided by 7. So let's 50 divided by 7. That's 7.14. 7.14 ohms. So that's our R equivalent, the total circuit are looking for, total circuit resistance. So the equivalent of all of this is what? 7.14 ohms. So we got 7.14 ohms. So this is what we got. So now let's use the other method I said. Then we'll continue from that other method. So we got 7.14 ohms. Let's write that 7.14 ohms. So now let's assume our resistance, our Y is in this direction. Okay, this direction we took before. Here's this direction we took before. Let's take the other direction anyways. So this, so by this is our R1, R2, R3. You don't need to calculate R1, R2 and R3 again. You've already got them. Your R1, you got it as what? 2 ohms. Your R2, you got it as what? If you remember, 2.5 ohms. Your R3, you got it as what? That's 10 over 3. That's 3.33. That's R3. So you have this already. It doesn't change. So now this is now one. So instead of using the Y facing up, and not using this Y, you can use any of them. There's no how you face a Y that is not correct. So let's look at our Y. You can even face it in this direction. You still get the same answer. So let's look at this. Plus minus 50 volts. Then you have your 2 ohms there. This is your 2 ohms. Then it's going to your R. This wire is not there again. This is not there again. And this is not there again. It's going to your what? R1. This is your R1. Then you have this like this. Your R2. You have this like this. Your R3. Then you have this coming down to your 3 ohms, and then to your 4 ohms, and you have it that way. So this is your R3, this is your 3 ohms, this is your 4 ohms. Then you now have this to complete the circuit. So now automatically you can see that these two, they are in series. R2 and these 3 ohm are in series. What's the R2? Your R2 is 2.5. What's the R1? Your R1 is what? 2. What's the R3? Your R3 is what? 3.33. So let's solve that. These two are in series automatically. That means these two now, your R equivalent 1 for those two up, R equivalent 1 will be equals to what? 2 plus 2. So for this one, it is what? 2 plus 2, and which is what? 4 ohms. Same current will flow through them. Also, these two are in series, the same current will flow through them, no branch. So that means the R equivalent 2 for these two. You're going to have it as what? 2.5 plus 3. And that's what? 5.5 ohms. Also for this, they are in series for 3. This and this are in series. That means the R equivalent 3 now will be equals to what? 3.33 plus 4. And that's what? 7.33 ohms. So now let's now redraw the circuit. Let's redraw the circuit. I'm going to have what? Your 50 ohm is still here. Your 50 volts, sorry. Then these two now has been combined to what? 4 ohms. Then the wire is coming down. Then you have this. These two has been combined to what? To 5.5 ohms. These two here. These two have been combined to what? 7.33 ohms. So those two. Then the complete circuit. So this is 7.33 ohms. And this is what? 5.5 ohms. And this is what? 4 ohms. Now these two are in parallel. So let's find the equivalent of this loop. So if you find the equivalent of that loop, you're going to have 1 over R equivalent, since they're in parallel, to be equals to 1 over 5.5 plus 1 over 7.33. What was 1 over 1.5? 5.5. 1 divided by 5.5. You're going to have 0.182. 0.182 plus 1 divided by 7.33. 1 divided by 7.333. That's 0.136. 0.136. So that means the 1 over R equivalent now is the addition of what? 0.182. That's 0.336 plus 0.182. That's 0.3184. 0.3184. So to get our R equivalent, I have to take the reciprocal of this. That means our R equivalent will be equals to what? 1 divided by 0.3184. 1 divided by 0.3184. That's 3.14. So that's 3.14. That means our R equivalent now. Our R equivalent now is what? 3.14. So that's our R equivalent, 3.14 ohm for these two. So let's now redraw our new circuit. Let me cancel this. So drawing our new circuit now, I'm going to have what? The 50 volts supply, 50 volts. Then the 4 ohm resistor combined with what? The combination of those two. So I'm going to have 4 ohms. The combination of these two give us what? 3.14. 3.14 ohms. So now these two are in what? They are in series. That means the total R equivalent that we're looking for is what? 4 plus 3.14. So that means our R equivalent is what? 7.14 ohms. So that's the R equivalent of this circuit that we have to find, which is the same thing as the first one we did. So we take your R equivalent in your star in this direction. If you use this as your star, you get your answer too. If you use this as your star, you get your answer too. So there's nothing you use as your star that will not give you your answer. So anything you use will give you your answer. So let's move to the next question. So let me draw a circuit here. You have a 50 volt source plus minus 50 volts. You are given I source, and you've calculated all these resistors. All the resistance as what? 7.14. The equivalent of all the resistance is what? 7.14. So you're going to have R equivalent here. R equivalent, which is equals to what? 7.14 ohms. So now you have to calculate the current that is flowing out of this source. So using Ohm's law, V equals to what? IR. So in this case of V source should be equals to what? I source times R equivalent. So make I source of the formula. That means your I source now will be equals to what? V source divided by R equivalent. That means your I source will be equals to what? What's the V source? The V source is what? 50 volts. What's the R equivalent? R equivalent is what? 7.14. That means your I source, the current from the source will be equals to what? 50 divided by 7.14, and that's 7. That's 7 ampere. So that means the supply current is what? 7 ampere. So that's the supply current. The source current you have to find is what? 7 ampere. Now you have to calculate the power absorbed by the what? By the 4 ohm resistor. So you have to know the power, the current that is flowing through here. So if you know the current that is flowing through this 4 ohm resistor, it will be easy for you to calculate the power absorbed by it. So for you to know the current flowing through this 4 ohm resistor, you have to use the first method. You have to redraw your R equivalent here. So let me redraw that. Okay, so I have to redraw that. Okay, let me redraw it here. Plus minus 50 volts. Then you have a 4 ohm resistor here. You have your R1 moving in this direction. You have your Y moving in this direction. Then you also have this moving in this direction. Then you have it connected to this, and you have it connected to this also. Then this completes the circuit. So this is 4 ohms. This is R1. This is R2. This is R3. This is 3 and 4 ohms. This is 3 ohms, and this is 4 ohms. So this is a circuit. Then we want to know the current that is flowing through this. Then we know our I source already as 7 amp. So if 7 amp is flowing into this circuit, it's flowing. Since this 2 is in series, that means that 7 amp will get to this 7 amp. So in this case, this 7 amp will be split into this and into this. But this, since these 2 are in series, that means the same current will be in this, the same current will be in this. So let's use current divider to divide the current. Now the one that will flow here and the one that will flow here. So let's go back to this circuit. We know that the combination of these two gave us this 5.5 earlier, and the combination of these two gave us this 7.33. So now that means the 7 amp reaches side. So let's now know the current that is flowing in this circuit, in this. So to know the current flowing here, I. So you have to use what? Current divider. So using current divider, your I will be equals to what? Call this R1. Let's call this RX, and let's call this RY. Since we want to know the current that is flowing through here, that means I'm going to pick here That's the law for current divider. You want to know the current flowing in this one, you pick here Ry. So that will be Ry divided by the sum, which is Rs plus Ry times the supply current I source. This is supply current there, which is this 7 amp that is being supplied I source. That means the current I that is flowing there now, because what's the Ry? Your Ry is what? Your Ry is 5.5 divided by what's the Rs? Your Rs is what? 7.33 plus what's the Ry? Your Ry is 5.5 times the source current, which is what? 7 amp. That goes to what? 5.5 times 7 divided by 7.33 plus 5.5, 33 plus 5.5, that's what? 12.83. So 5.5 times 7 divided by 12.83, 5.5 times 7 divided by 12.83, that's what? 3. That means the current supply there was what? 3, sorry, that's 3 ampere. So that means the current supply in this is what? 3 ampere. So the current supply is in 3 ampere. Note that this is a combination of 2 resistors. And what was those 2 resistors? These 2 resistors gave us that 7.33. And since these two are in series, that means the same current that is flowing in this will flow in this. Since they are in series, that means the current flowing, current in resistor 4 ohms, is what? 3 ohms. 3 amps, sorry. The current flow in this 4 ohm resistor that I want to, so that means the current flow in this 4 ohm resistor is what? Is 3 amps. So we can now know the power. What's power? So let me do that here. So you can now know the power. What's power? Your power is what? I square R. So we want to know the power in the 4 ohm resistor. So do you know the current? We know the current. What's the current? The current is what? 3 amp. That's 3 square times what's the resistance? The resistance is 4. So that means your P now equals to what? What's 3 squared? That's 9 times 4. What's 9 times 4? 36. That means the power is what? 36. That means the power absorbed by the 4 ohm resistor is what? 36 watts. So let's move to example 2. Example 2, we have to determine the what? The total resistance, the total circuit resistance for all this. We have to calculate the equivalent of all this and the source current. So if you know the equivalent resistance, then we can calculate our source current. Very easy. So let's start by calculating the source current. Now in this case, we don't know, maybe this and these are in series, or these are this in series, or they are in series. We don't know, but we know that this is data. This is data. We can convert it to Y. This is also data. We can convert it to Y, or better still, we know that this is Y. This is Y, whereby you have this connected to this and this. This is just a straight line that if you spread this to this straight line, so this is Y. So we can convert it to what? We can convert this to data connection. There's no way you can do it. Just make sure you are following the procedure. So okay, let's convert from this data. Okay, let's convert this to Y, this to data. Let's convert it to data. Let's convert it to this. So if you want to convert it to data, we're going to have what? If you want to convert data, you're going to have this. So this is your data connection. So we are going to, this is what you are going to have. So this will be your data connection, whereby this wire won't be there again, this wire won't be there again, this wire won't be there again, and this wire won't be there again. So let's do that. Now from our From y to data, what are we going to have? From y to data, our r, okay, let's call this our ra, let's call this our rb, and this is our rc. So now from y to data, let's call this our r1. We want to know r1, this one r2, and this is r3. So from y to data, now you're going to have what? R1 to be equals to RA RB plus RC RB RA RC plus RB RC divided by what? Divided by RA. Note that your R2 will be equals to what? Everything here divided by RA. So let's call everything up RC. So divided by RB now, instead of RA to be RB. Whereby your R3 now will still be what? Everything up here divided by RC. RT divided by RC. So what changes were RA, RB, RC. Let's go back from Y to data. So from Y to data, so from Y to data, you notice R1, R2 plus R2, R3 plus R3, R1. So note that all this and all this and all this are the same. What differs is just the R2, R3 and R1, and you can change it anyhow. You can write it directly RA, RB, RA, RC, RB, RC. You can write it, you can write this before this before this, and your RA, RB and RC, you can interchange them, but don't use RA twice and don't use RB twice or RC twice. So let's find our RT. Our RT, I said my RT is what? I've changed my RT to be equals to what? RA RB plus RA RC plus RB RC. So now my RT now be equals to what? RA times RB. What's RA? 7. What's RB? 10. That's 7 times 10 plus RA times RC. What's RA? 7. What's RC? 3. That's 7 times 3 plus RB times RC. What's RB? 10. What's RC? 3. That's 10 times 3. So that means RA equals to what? 7 times 10. That's 70 plus 7 times 3. That's 21 plus 10 times 3. That's 30. So if you have that, your 20 plus this, so 70 plus 21 plus 30, that's 121. So that means our R total is what? 121 ohms. So that means our RT, this is RT, is what? 121. So that'll be 121 divided by RA. What's our RA? Our RA is what? 7. Our RA is 7. So 121 divided by 7 divided by 7, 121 divided by 7, that's 17.3. So that means our R1 is what? 17.3 ohm. Okay, same way our R2 because to RT, sorry, RT, that's 121. Our RT is what? 121 divided by RB. What's our RB? 10. So 121 divided by 10 will give us what? 12.1 ohm. Also our R3 will RT, which is what? 121 divided by RC. What's our RC? Our RC is 3. So 121 divided by 3, I'm going to have what? 121 divided by 3. So that means that's 40.3. 40.3 ohms. So our R3 is what? 40.3. So let's draw our circuit. Let's draw this circuit to see what we have. Plus minus 45 volts, then 45 volts, then you have a 5 ohm resistor there. This is supply current IS. You have 5 ohm resistor here, 5 ohms. Then this came to this. There's no, this wire is not there again, so it came to this. Then from here, your data, which is R1, this is R1, whereby R1 is what? 17.3. So this is 17.3. So this is your R1. Then down here, so you have 8 ohms here, 8 ohms. this 8 ohms, so this 8 ohms here, then this like this, R3, R2 which is what, 12.1, R2 which is equals to what, 12.1 ohms. Then you have R3 here, R3 which is what, 40.3 ohms. Then you have this again, this is still there, is only this wire and this wire we converted to that, so we still have this, so this wire is still there, which is 6 ohm, and this wire is still there, which is 4 ohms. Then this 4 ohms. So is this wire, let me rub that off. So is this that has turned to this data here. So this is what we have, we've turned this Y to data, so that's why we have this. So when looking at this, we can notice that these two, they are in series, so that means the R equivalent there for those two, for this, will be what, 6 plus 4, which will give us what, 10 ohms. So we can replace these two as what, 10 ohms. So let's replace that immediately. So these two now, it gave us what, 10 ohms. So those two give us 10 ohms. So those two now, it has been replaced with what, with 10 ohms. So this is what, 10 ohms. Also, what can we see directly is that these two now, they are in parallel. So let's calculate the parallel and get our equivalence for these two, for this loop. They are in parallel, so that means our 1 over R equivalent will be equals to what, 1 over 12.1 plus 1 over 10. So what is 1 divided by 12.1? Let's calculate that. 1 divided by 12.1, that's 0.083, 0.083 plus 1 divided by 10 is what, is 0.1. so if we add that together, so that means that 1 over R equivalent will be equals to what, 0.183. so if you take the reciprocal of this, that means your R equivalent will be equals to what, to be equals to, sorry, let me write it here. So that means your R equivalent will be equals to what, 1 divided by 0.183. so if you just calculate the 1 divided by 0.183, 1 divided by 0.183, so you're going to have 5.46. so that means your equivalent is what, 5.46 ohms. That's the equivalent resistance for these two loop. So for this two loop, we got what, 5.46. so we have to replace this two loop, this wire here now, we replace it with what, just a single resistance, which is what, 5.46. so let's do that. So that two now, we replace it with just one single resistance, sorry. So the combination of these two that we calculated just now gave us what, gave us just one resistance, which is what, 5.46 ohm. Now we can notice that these two now, they are in what, they are in series, the same current will flow through them. So if the same current will flow through them, you can calculate their R equivalent, these two, this and this. So that means the R equivalent now for these two now, for this and this, will give us what, 5.46. they are in series, you add them together, 5.46 plus 40.3. so that means the R equivalent will be equals to what, 5.46 plus 40.3, that's what, 45.76. that's 45.76 45.76 ohm. So that means the equivalent of these two gave us what? 45.76. So we replace these two with just one resistance. So let's replace those two with that one resistance. So those two, now we replace it with just one single resistance. So if we replace that, we are going to have just one single resistor, which is this. So that means this is what? 45.76 ohm. Now you can notice that these two now they are in parallel, so you can use parallel method to solve them. This loop now they are in parallel, so let's solve that parallel. Let me create chance here. We don't need this again. We already know what our R1 is, R2 and R3. So let's create chance. So let's calculate the R equivalent for this loop. So 1 over R equivalent will be equals to what? 1 divided by 17.3 plus 1 divided by 45.76. So let's calculate that. 1 divided by 17.3, 1 divided by 17.3, I'm going to have what? 0.058. That's 0.058 plus 1 divided by 45.6, 0.058. So let's have the other one. 1 divided by 45.76. You're going to have 0.022. That's 0.022. 0.022. So if we add these two together, that means the 1 over R equivalent will be equals to what? 0.058 plus 0.0, so that's plus 0.058. That's what? 0.08. So that will be 0.08. 0.08. So with that, take the reciprocal to now R equivalent. That means our R equivalent will be equals to what? 1 divided by 0.08. So what is 1 divided by 0.08? We're going to have 1 divided by 0.08. That's what? 12.5. That means our R equivalent is what? 12.5 ohms. So that means these two resistance give us what? 12.5. So if they give us 12, if they give us 12.5, we're going to replace it with what? One single resistor. So let's replace that with one single resistor. So let's assume we want to replace this with one single resistor. That will be equals to what? So these two give us just one single resistor, which is this, which is what? 12.5 ohms. Now note, these three now they are in series. The same current will flow like this. That means our R equivalent that we need to know, the total resistance of the circuit is now what? R equivalent will be equals to what? This plus this plus this. That's your 5 plus 12.5 plus 8. That means the R equivalent now will be equals to what? 5, okay, plus 5 plus 8. That's 25.5. 25.5 ohm. So that means the total equivalent of this circuit is what? 25.5 ohm. So let's draw it in the other side. We have a 45 volt battery. We have a battery source plus minus, which is 45 volts. You have a current supply, which is the I source. Then note, we've calculated all this as our R equivalent for this 25.5. So instead of that, we're going to have all of that to be replaced with what? R equivalent. R equivalent, which is what? Which is 25.5 ohms. So we have to calculate our I source. So we've calculated the total circuit resistance. That's the R equivalent. Now we have to calculate the source current, which is this. So using Ohm's law, let's assume this is our battery source. Ohm's law says that your V equals to what? Equals to IR. Your V equals to IR. Whereby this is your V source in this case. equals to what? The current source times the R equivalent. So make your I source the subject from now. That means your I source now equals to what? Your V source divided by what? Divided by R equivalent. So we divide that, your I source because what's of V source? That's 45. Then divided by your R equivalent, which is 25.5. So we divide. So your 45 divided by 25.5 will give you 45 divided by 25.5. That's what? No. 45 divided by 25.5. That's 1.76. 1.76 ampere. So this is supply current. So that means our I source from the battery is what? 1.76 ampere. So that's the supply. Sorry. .76 ampere. So that's the supply current from the battery. So let's move to the practice question. This is a practice question. So what's the difference between this question and that? You've been added this, and note the kind of connection you have. This is a data connection, so you can convert it to Y, or you should use this. This is your Y connection. This is Y connection. Convert it to data and see what you're going to have then solve. So you have to calculate the equivalent resistance. So you have to calculate the equivalent resistance of all these circuit, of all the resistors, and the source current. So if you know the equivalent resistance, the source current is not hard to find. So solve that and let me see what you get. If you have any issue, you can contact me. Practice question. This is also another practice question whereby you have a data here, a data here, a data here. So you can convert them to Y. You can just convert one of them to Y. If you need to convert the 3 to Y, you can't convert the 3 to Y. If you convert this to Y, then this will be short. So that you can convert this to Y and this to Y and see what you have. So convert these two to Y, this aspect to Y, this aspect to Y, and solve and see what you're going to have. So calculate the equivalent resistance and the source current. So let's move to source conversion. So in source conversion, you convert from current source to voltage source, and also convert from voltage source to current source. So that means you have a voltage source plus minus, you are going to convert it to what? A current source. If you have a current source to convert it to what? Voltage source. So we are going to do both way. Now, voltage and current sources are connected in electrical circuit based on the application requirement. So we use voltage sources and current sources. For circuit analysis, sometimes these sources need to be converted from one form to another to simplify the circuit configuration. This task can be performed using a source conversion technique. So there are sometimes you need to convert from voltage source to current source, so to reduce the task, to make the work more easier than just doing it directly. So let's start from the first one: voltage source to current source, and also current source to voltage source. We do the two together. So now this is a voltage source. Now one thing you should note that if you want to convert from voltage source to current source, your voltage must be in series with your what? Resistance. And when you are converting to current source, that means the current will be in parallel to what? To the voltage. The current will be parallel to the resistance. So if this is your voltage source, this is a voltage source, so it will be in series with your voltage. So if you convert it to parallel to current source, that means this will be the current and this will be what? Your resistance. It will be in parallel, not series. So if you are converting from current source also to voltage source, your current source must be in parallel to what? To your current source must be in parallel to the resistor. So when you are converting back, that means your voltage source will now be in series. So this is how to convert both ways. Now let's assume you want to convert from this to this. You want to convert from your voltage source to current source. So you are going to have a current source and then the resistor in parallel. This is how you are going to have it. Now the resistor value does not change, it's still R. So what will now be your current? You use Ohm's law, V equals to IR, right? So that means the current will be equals to what? V over R. So because of this voltage source divided by this resistance, voltage source divided by resistance, that will be your current flowing. Now also if you want to convert from voltage source from current source to voltage source. From this now, you're going to have what? Let's assume this is I want to convert it to what's his name, to voltage source. So your resistor will be in series. If you are converted to voltage source, then you have this. So plus minus. So this will be what? R. The resistor did not change, but your current source now, your V, using Ohm's law, equals to what? IR will be what? Which will be equals to what? The current source times resistance, which is I source times R. So that's how to convert. So let's look at some example. So example one. So let's look at this. We are given a series parallel circuit with voltage and current sources shown in the figure below. Use the source conversion technique to find the current in the 8 ohms. So we want to look at the current in this 8 ohm resistor. So we are going to use what? The series and source conversion. So how do we do that? So we convert all our current source. These are current source parallel to your resistor. You convert it to a series with voltage source. So you convert it to something like this, plus minus. So this will be a voltage source, and this will be your resistor R. So that doesn't change. Your R does not change. So let's convert that. Let's convert this. So we'll convert this directly, and we'll convert this. Also, we convert this to current source. Let's convert this to current source. Let's do the conversion. So we convert this now to current source. You're going to have a current in parallel to what? You are going to have a current in parallel to this resistor. So this will be a current source. So it will be in parallel to this. So this conversion gave us this, and this does not change, 3 ohms. And I said, how will you get your current? You have to use Ohm's law for this. V equals to what? IR. So what is your I? Your I is what? V over R. What's the voltage? Voltage is 30. So 30 divided by, what's the resistance? The resistance is what? 3. So that's 30 divided by 3, and that's what? 10 amps. So this will be what? 10 amps. So we've converted this. So now draw this. We'll continue with our drawing. This is now your 4 ohms. This 8 ohms, we draw it again. 8 ohms. Then we'll draw this. We can also convert this directly. We can convert this. This is in series. So we convert this to current source. I'm going to have a current, a resistor in parallel to what? To a current. Something like this. So whereby this of 5 ohms does not change. This is what we converted to this too. Then this 4 ohms, this is 8. This 8 ohms, this is 8. Now also I converted this to what? To current source. That's why I have this. Whereby this 5 ohms will not change. It should be 5. So now what will be our current? Our current will be equals to what? VI equals to V over R again. The voltage source divided by the resistance. What's the voltage source? That's 10 divided by 5. What's 10 divided by 5? That's 2 amps. So that means the current flowing here will be what? 2 amps. So let's convert this also. Now this will be converted to what? To voltage source. We'll convert this to voltage source. We'll convert this to voltage source. We're going to have what? A resistor in what? In series to what? To a voltage source, plus minus V. So you have this, but this won't help us. Let's look at this very well. This and this is in parallel, we know that, but converting this back will not help us to solve any problem. It will not help us. So let's make sure that we convert this to series and leave this alone. If we convert this to series, that means this will be in this direction, and your voltage source will be here, plus minus. Will that help us also? No. But let's leave this alone. Let's leave this alone, and don't let us convert this. If we don't convert this, we are going to have, let me rub that off. So let's start from there again. So from these 4 ohms, let's move to this side. So let's convert this 10 volts and 5 ohms to current source. So that means this will now be our current source in parallel to what? To the 5 ohms. like we did earlier. So this will be 5 ohms, and this will be what, 2 ampere, as we calculated earlier. So if we convert this 2 is converted to this. So let's leave this alone. So this will be what, 2 ohms, and the current source also, which is 2 amp. And by this is what, 2 ohms. So we know that this and this are in what, they are in parallel. Then we can calculate the equivalence of that. So let's calculate the equivalent of this, please. So we are going to have 1 over R equivalent to be equals to what, 1 over 3 plus 1 over 4, and that equals to what, the same is what, 12. So 3 in 12, that's 4 times 1, that's 4, plus 4 in 12, that's 3 times 1, that's 3, that's equals to what, 7 over 12. So take the reciprocal, that means the R equivalent will be equals to what, 12 over 7. And what's 12 over 7? 12 divided by 7, that's 1.71 ohms. So the equivalent of these two give us what, 1.7 ohms. So let's remove that and put that. So these two now give us 1.71 ohms. The equivalent of these two give us, so the equivalent of those two give us, so instead of having those two, we are going to have this, which is what, 1.71 ohms. Now these two also, they are in parallel. Let's find the equivalent. So that's 1 over R equivalent to be equals to what, 1 over 5 plus 1 over 2. They are in parallel. So what's the SCM? The SCM is 10. 5 in 10, that's 2. 2 times 1, 2, plus 2 in 10, that's 5. 5 times 1, 5. So we add that, that's 7 over 10. If we take the reciprocal, that means the R equivalent will be equals to what, 10 over 7. And what's 10 over 7? 10 divided by 7, that's 1.43 ohms. That means these two give us what, 1.43 ohms. So let's replace that with just one resistor. So these two give us 1.43 ohms. So instead of having those two, you have what, 1.43 ohms. So that's the equivalent of these two. So now we can convert this back to voltage source. So if we convert this back to voltage source, it will make it to be in series with this. So let's convert this back to voltage source. Let me rub off this. We are through with this. So let's convert this back to voltage source. So let's convert that back to voltage source. So we convert this back to voltage source, you're going to have your voltage plus minus in series. So this will be your V in series with what? This. So that's conversion of this back to voltage source, as we said here. We want to convert from this to the of Vs in series with that. So that's how we have this. And what's your V? Your V is what? The current times the resistance. Your V equals to IR. And what's your I? The I is 10 amp times what's the resistance? 1.71. So if we multiply that, I'm going to have what? 17.1 volts. So that means the voltage is what? 17.1 volts. And what's the resistance? It does not change. That's 1.71. 1.71 ohms. So that's the combination. Then let's continue our diagram. And this is here, which is what? 8 ohms. So let's convert this back to also to voltage. So if we convert it to voltage, so that we are going to have a resistor in what? In parallel to your voltage source, plus minus voltage source. Or sorry, we did not know the polarity of our current. Look at this, minus plus. That means this direction of our EMF. that means the current will flow in this direction. That's why this is flowing in this direction. So look at this. These are minus plus from our EMF. That means our EMF is flowing in this direction. That means our current, this current is meant to be flowing downward. Sorry, I did not explain that. So note the direction of your EMF. That means this current is meant to be flowing downward. So we are now converting this back. When we are converting this back, that means it's meant to be minus plus, because the direction of the EMF is what? Downward. That is minus, then plus. The direction of the EMF is what? Downward. Then let's draw this downward, which is what? 3 amp. It's 3 amp. We did not do anything to it since morning. 3 amp. Downward also. So now let's know our this one is minus plus is because the direction of the EMF is what? Downward. So the resistance will not change, which is 1.43, and the voltage now it equals to what? The current times resistance. Your V will now be equals to what? IR. So the voltage will be equals to what? What's the current? That's 2 times R, which is what? 1.43. We multiply that means your V because to what? 2.86 voltage. That means the voltage will be what? 2.86. So you can use KVL for this loop to know the current flowing in this circuit. So to use KVL, you are going to have, or better still, to remove that, there's something you should do. Let me start back from here. Now from here, so let's go back to this direction, to this. So you understand the direction now. This is meant to be moving downward. Then these are wires, you can exchange them. Maybe you bring this 1.43 here, 1.43, they are just wires, they can be exchanged. 1.43 ohms. Then these 2 amps, then this last one 3 amps. So these 2, these 3. So these 2 can be combined together as one, since they are moving in the same direction. This is moving downward, this is moving downward. That's, if you combine them together, you give you what? 5 ampere. So you combine that together, you're going to have these 2 now. You combine them together, you have what? 5 ampere. So the combination of those 2, since they're in the same direction, as when one is moving upward, it will be 3 minus 2. So the combination will be what? 5 ampere, which is 2 plus 3. This is 3 amp. They are in the same direction. 3 amp given, and that will be what? 5 ampere. So if you combine those 2, then you cannot convert this to what? A voltage source. So let's convert it to voltage source. If you convert it to voltage source, you're going to have, okay, let me convert. Okay, let's convert it, this to voltage source. If you convert that to voltage source, you're going to have a resistor here and the voltage source. Since they are moving downward, the current is moving downward, that means it will be minus plus. That's the direction of the current. That's why check this polarity, it's very, very important. The current is moving downward, the 5 amp current. So that's the direction, that's from negative to positive. That's why it's minus plus. Then this resistance will not change to be 1.43 ohms. So now the voltage now equals to what? V equals to IR. Sorry, V equals to IR. What's the current? The current is what? 5 ampere. 5 times the resistance is what? 1.43. 1.43. So you multiply that. 5 times 1.43. 5 times 1.43. That's 7.15. That means this is 7.15 voltage. So now we can now write KVL for this loop to know the current flowing in this loop. So if you know the current flowing in this loop, since they are in series, the same current will flow through them all. So let's write KVL for this loop. So we write KVL for this loop, this direction of this EMF, this direction of this EMF. So let's start. This, the direction of the loop and direction of the EMF are in the same direction. We are going to have 17.1, a voltage drop here which is 1.71 I, a voltage drop here, that's minus 8 I, a voltage drop here minus 1.43 I. Then the loop and direction of EMF and the same direction, so that will be positive plus 7.15 to be equals to what? Is 0. So add these two together, that's 17.1 plus 7.15. Then minus 1.7 minus 1.71 minus 1.71 minus 1.71 minus 8, 1.71 minus 8 minus 1.43 will give you minus 11 minus 11.14 I to be equals to what? Is 0. So make 17.1 plus 17.1 plus 7.15, that's 24.25. Then bring this to this side, I'm going to have 11.414 I. So make I 0 from now, that means your I, the current flowing, equals to what? 24.25 divided by 11.14, and that's what? Divided by 11.14, that's 2.17, 2.18, approximately 2.18 amp. So that's current flowing in this, and it's the same current that will flow in this 8 ohm resistor. That's current flowing in the 8 ohm resistor. So the current is 2.18. So you can use any other different method to solve it and see if you are going to get the same answer. You can use superposition. Use superposition and try the current that is flowing through. If you want to use superposition, what are you going to do? You short circuit this. You short circuit this. And now find the effect of this. Later, you open circuit this. You short circuit this, and you find the effect of this. Later, you open circuit this. You short circuit this. You find the effect of this, and add all the daily current you get that is flowing here. So that's how you use superposition. So you can use superposition to solve this and see if you're going to get the same answer as this. So let's move to the next example. Okay, this is a practice question, not example. So you practice this using source conversion also. There's a simple way to solve this actually. This is Y connection. You have just change it to what? To data connection. But since you want to use series parallel conversion, to use conversion way to solve it. Sorry. So you use conversion way to solve this. So you have to convert this to what? To current source. Also you convert this to what? To current source. So if you convert that to current source, it will be easier to solve. Then see what happens next. So let me solve this question with mesh analysis. Then you can use this method, this series parallel conversion method, to solve it. But I'll use mesh analysis to solve it. So let's say this is our first loop, and this is another loop. Let's call this current I1 is flowing here, current I2 is flowing here. So now let's use loop analysis. This is the direction of our EMF from negative to positive. This is the direction of our EMF from negative to positive. Then let's write the KVL for this loop. For loop 1, the KVL. What will be the KVL? Now the direction of the loop and the direction of the battery is the same, so we are going to have 40. There will be a voltage drop here, which is 5 times I. V equals to IR, 5 times the current that is flowing, that's minus 5 I1. There will be a voltage drop here, which is 6 times IS. And what's our IS? I1 is moving downward, but this is opposing it. So that will be I1 minus I2. So the current here will be what? I1 minus I2. That means minus 6 into what? I1 minus I2. Then there will be a voltage drop here, which is 3 times the current moving through it. What's the current moving through it? That's just I1 minus 3 I1 to be equal to what? Is 0. So this I1, I2, I1. So let's open the bracket. We're going to have 40 minus 5 I1 minus 6 I1. If you open this bracket, that's plus 6 I2 minus 3 I1. 3 I1 to be equal to what? Is 0. So now let's collect like times. Minus 5 I1 minus 6 I1 minus 3 I1 will give you what? Minus 5 I1 minus 6 I1 will give you minus 11 I1. So the minus 3 I1, you're going to have what? Minus 14 I1. So you have 40 minus 14 I1. Then you have this plus 6 I2 is equals to what? Is 0. Rearrange this equation. Bring this to this side. You're going to have what? 40 to be equals to what? 14 I1. So if this cross to this side, you're going to have minus 6 I2. So if you rearrange this, you're going to have divide everything by 2. You have 20 to be equals to what? 7 I1. If you divide it all by 2, because 2 can go through them, minus 3 I2. So you can rearrange this. That means just 7 I1 minus 3 I2 is equals to what? 20. That's the equation 1. So let's write the same thing for our loop 2. So KVL for loop 2. So the KVL for loop 2. For your loop 2, let's start from here. This is the direction of our loop. Our loop is moving in this direction and the same direction as your EMF, so that will be positive. That's 30. There will be a voltage drop here, which is 6 times the current that is flowing through it. So your I2 is flowing upward, but this is opposing it. That's I2 minus I1. So minus 6 the resistance times the current, which is I2 minus I1. A voltage drop here, which is 10 times the current that is flowing through, which is just I2 minus 10 I2 to be equals to what? Is 0. So let's open this bracket. We're going to have 30. Open this bracket. That's minus 6 I2 minus, no, that's plus, minus times minus plus, then 6 times I1 plus 6 I1 minus 10 I2 to be equals to what? Is 0. So let's collect like times. We are going to have 30, then minus 6 I2 minus 10 I2, that's minus 16 I2, then plus 6 I1 to be equals to what? Is 0. So that's how we have this. So rearrange this, bring this 6 I1 here. They're going to have 6 I1 minus 16 I2. So bring this to this side. I'm going to have 2 equals to what? Minus 30. 2 can go in everything, so divide all through by 2. So I'm going to have what? I'm going to have 3 I1 minus 8 I2 to be equals to what? Minus 15. So this is the equation 2. So let's solve these two equations simultaneously. So let's solve them simultaneously. Sorry, let me remove this. So let's solve those equations simultaneously. Here are the two equations. You have 7 I1 minus 3 I2 equals to 20. 7 I1 minus 3 I2 to be equals to what? 20. What's the equation 2? That's 3 I1 minus 8 I2 equals to minus 15. 3 I1 minus 8 I2 equals to what? Minus 15. So you have those two equations. So we have these two equations, so let's solve them simultaneously. So This is the equation 1. This is the equation 2. So to solve simultaneously, multiply this by 3 and this by what? By 7 to cancel out the I. So 7 times 3, that's 21I1 minus 3 times this, that's 9I2. Then 20 times 3, that's 60. The same thing as the 7 times 3, that's 21I1. 7 times 8, that's minus 56I2. I2 to be equals to what? 15 times 7, that's minus 105. Minus 105. Then subtract 21 minus 21. This return is to plus. This minus times minus plus. Also this minus times minus also plus. So 21 minus 21, this will be 0. Then minus 9 plus 56. Minus 9 plus 56, that's 47 plus 47 I2 to be equals to what? 60 plus 105. 60 plus 105, that's 165. So I'm going to have 0 plus 47 I2, that's 47 I2 to be equals to what? 165. So your I2 be equals to what? 165 divided by 47. What's 165 divided by 47? That's 3.51. 3.51 ampere. So that's our I2. So we need to know our I1. So you can pick any of these equations. So let's pick equation 1. So from equation 1, your 7I1 minus 3I2 is equals to what? 20. So solve for I1 since you know I2. That means your 7I1 minus 3. What's the I2? That's 3.51. 3.51 is equals to what? 20. That's 7I1 minus 3 times 3.51. That's 10.53 minus 10.53 is equals to what? 20. Bring this to this other side. So you have your 7I1 to be equals to what? 20 plus 10.53. So that means your 7I1 is equals to what?
Power off.
The 7I1 is equals to what? Plus 20. That's what? 30.53. 30.53. So that means your I1 will be equals to what? 30.53 divided by 7. That means your I1 is what? Your I1 equals to 4.36. 4.36 ampere. So now we want to calculate our IS. What's our IS? Our IS is current flowing here. And what's the current flowing here? Which is I1 minus I2, because I1 is flowing downward, then I2 is flowing what? Upward. So that's I1 minus I2, because this is the direction of our IS. So that's I1 minus I2. So our IS is what? Is what? I1 minus I2. So that means our IS is, what's our I1? I1, and this is I2. What's our I1? That's 4.36 minus, what's our I2? That's 3.51. That means our IS now is what? Minus 4.36 minus 3.51. That's 0.85. 0.85 ampere. So that's our IS, 0.85 ampere. So that's the current flowing through this IS. Let me cancel this. So that's the current flowing through this resistor, this 6 ohm resistor. You have to find 0.85. So use this series parallel conversion, convert this to parallel, analyze it. You must get the same answer as 0.885 ohms. So this is the end of the lecture. Thank you.